All right, remote calculus, welcome to what is probably going to be a long one here. Chapter 3 exam review video. You were emailed something like this, remote calculus, Chapter 3 exam review, spring 2021, this Friday at 1:15 via the Google Meet. 1:15, we're going to start a little bit earlier. There, 1 through 26, find the derivative. So at the top, I've written each individual f of x, and then showing you the work. So this first one is simply the power rule. Bring, 4 times 6, 24, 1 power less. 2/3 times 3 is 2, 1 power less. 2 times 6 is 12, 1 power less. 1 times 7. Negative 7 is negative 7. X to the 0, which is just a negative 7 there. So that is my answer. All right, here on number 2, we want to rewrite negative 4 over x to the third plus 2 over x squared as negative 4x to the negative third plus 2x to the negative second. Then bring down the power, 1 power less. Bring down the power, so it's a minus 4, 1 power less. And since my original function didn't have negative exponents here, let's rewrite it as 12 over x to the fourth minus 4 over x cubed. That is my derivative. All right, so on the easier side there, not using the product or the quotient property, just doing a simple power property. So the fourth root of x to the third minus 3x squared can be rewritten as x to the 3/4. Bring down the power. 3/4 times 1 is 3/4. Subtract 1 from 3/4. We got negative 1/4 as the power. Bring down the power, 1 power less. So again, I'm just rewriting it as 3 over 4x to the 1/4 minus 6x. Let's take a look at number 4. You have the square root of x to the third minus 5x cubed all over x squared. I'm going to rewrite this first off as x to the 3/2. And then I'm going to take away 2 from each exponent. So this is now x to the negative 1/2 minus 5x. Bring down the power, 1 power less, negative 1/2 x to the negative 3/2 minus 5, x to the 0. All right, so you can write like that, or negative 1/2. This negative exponent will go south. X to the 3/2 become positive. All right, so again, no product property, no quotient property. Quotient rule, no quotient rule needed there. All right, number 5, again, this should match up with your document there. I'm going to rewrite it as x to the 1/2, and I'm going to, and minus 2x to the 1/2, then I'm going to distribute. Add the exponent. This is from Chapter 5 in Honors Algebra 2. All right, 2x to the 7/2 minus 2x. Bring down the power, 1 power less, so 7x to the 5/2 minus 2x to the 0, or minus 2. All right, let's go to number 6. Number 6, chain rule time. If you have u to the third,
Just a reminder, I will be meeting with those teachers interested in the summer school program in the radius room here on Thursday.
All right, so if you have any u to the third, the derivative would be 3u squared, the derivative of that u with respect to x. So I bring down the 3. I rewrite my u, 1 power less. Then I have to take the derivative of this with respect to x, which is a negative 3. Chain rule says you got to take the derivative of everything, all right? We'll kind of see that as we go. So how you have to clean this up is you do negative 3 times 3 to give you negative 9. And then 4 minus 3x, all of it squared. 7, you definitely have to do the quotient rule, which says low d high minus high d low, all over the square of what's below. D as in derivative, low for the denominator, high for the numerator. All right, so low, so the denominator times the derivative of the top, 16x minus 3, minus the top, that's high. D low, derivative of the denominator would just be 2, all over the denominator squared. Then FOIL it up, okay? distributes, that's just algebra 2. There would be my answer. Low d high minus high d low all over the square of what's below. Now on 8, honestly, yes, you could do the product rule, derivative of the first times the second plus the first times derivative of the second. We would call this the first, not the second. But then you still got a lot of cleanup, so you might as well just distribute. We had some that maybe didn't look as aggressive as this in Honors Algebra 2, Chapter 5 as well. But I'm going to multiply 2 terms by 3 terms, gives me 6 terms, which I simplify. And then I'm going to just use the simple power rule there. Bring down the power 1 power less, and that is my derivative. So I recommend that. Now, if this was being, if you had 3 terms being raised to the second, 3 times 3, that's 9 terms. Then we'd want to do A, if it was just that, like a chain rule. And then if I had that there, then a product rule as well. All right, number 9, again, I'm dividing by x to the 1/2, which means I can take a 1/2 away from all the powers of x. So take 1/2 away, 3 over 2 minus, that's to the first, take a 1/2 power away, plus, that's x to the 0, 0 minus 1/2 is x to the negative 1/2. All right, bring down the power, 1 power less, bring down the power, 1 power less, bring down the power, 10 times the negative 1/2, so minus 5, 1 power less. Honestly, that's a fine answer. Okay. And moving on. Here you have 1/2 sine u. The derivative of any sine u, again, used like for an angle, would be cosine u. Derivative of that u or that angle with respect to x. Okay, so it would be, what's that? 1/2 cosine u. Then I'd take the derivative of this with respect to x, which would be 6x. Half of 6x is 3x. Cosine 3x squared. 11. Unless we have the cotangent derivative down, we are going to do quotient rule. So low, derivative of the top. So negative 2. Derivative of cosine x is a negative sine x. Minus high, derivative of the bottom would be 3 cosine x, all over the square of what's below. All right. Negative times the negative is a positive. 2 times 3 is 6. Sine x times sine x is sine x squared. Negative times a negative is a positive. 2 times 3 is 6. Cosine times cosine is cosine squared. Factor out the 6 they have in common. We need to know that cosine or sine squared x plus cosine squared x is 1. That is the Pythagorean identity from pre-calculus, from trig. 6 over 9 sine squared x, which is 2 over sine squared x, or 2/3 of cosecant squared x. I would take any of those. Those are fine. All right, take a look at 12. 2/3 e to the u minus 1/2 e to the u. The derivative of any e to the u is e to the u times the derivative of that u with respect to x. So 3 e to the 3x minus 1/2 e to the u, and I take the derivative of this u, which is negative 4x with respect to x. That derivative is negative 4. And then I simplify. 13, I have to use the product rule. I call that my first function, that my second function, 2 kind of distinct functions in terms of x. Product rule says derivative of the first. So leave the 1/2. Derivative of x to the fourth would be 4x to the third. So derivative of the first times the second plus the first. Then times the derivative of the second. Derivative of e to the 3x would be e to the 3x times the derivative of 3x, which is 3. And then just clean it up. That is 1/2 of these derivatives. All right, take a look at 14. Gonna have to use the product rule again. Think of 2x to the third is kind of my first function, the natural log of 3x squared as my second function. So derivative of the first times the second plus the first times derivative of the second. Derivative of the first would be 6x squared, natural log of 3x squared would be the second. Derivative of the first times the second plus the first times the derivative of the second. Derivative of any natural log u is 1 over u, and then the derivative of u with respect to x. So 1 over u, and then the derivative of this with respect to x. Okay? This just simplifies to be the same. 2 times 6 divided by 3 is 4. X squared to the third times x divided by x squared is x to the second. All right, on 15, let's take a look here. Derivative of any cosine would be negative sine u, derivative of u with respect to x. So put that negative 1/3 on the outside. Derivative of cosine would be negative sine u. Then I take the derivative of this with respect to x, 9. Negative times the negative is positive. 1/3 of 9 is 3. So we got some trig functions here in a row. Let's take a look at 16. Derivative of any tan u is secant squared u times the derivative of u with respect to x. All right, so -3 secant squared u times the derivative of this u with respect to x. -3 times 2 is -6. Secant squared 2x. So that's the answer. Then 17 is this. 17 is 1/2 secant u. The derivative of any secant u is secant u tan u times the derivative of u with respect to x. All right. So we got 1/2. Secant u tangent u. Then I take the derivative of this u with respect to x. Derivative of 2x squared is 4x. 1/2 of 4x is 2x, secant u, tan u. All right, take a look at 18. 3x sine x cubed. Product rule. Derivative of the first times the second plus the first times derivative of the second. Derivative of 3x is just 3 times the second plus the first, which is 3x, times the derivative of the second, which I made a mistake. Let's clean that up. So the derivative of sine is cosine. Derivative of sine u is cosine u. Then I take the derivative of this u with respect to x, which is 3x squared. All right. Take a look at 19. Going to be using the quotient rule, which says derivative or low, d high, derivative of -2 cosine. Derivative of cosine is a negative sign, so a negative times a negative is a positive. It would be 2 sine x minus high, d low. Derivative of the denominator is cosine x. Now that's just the top all over sine squared x, so we're going to put that at the bottom. Let's take a look at the top. You again have 2, if we distribute, 2 sine squared x minus cosine x plus, because a negative times a negative, 2 cosine squared. Again, this would be the following. Sine squared x plus cosine squared x is 1. 2 times 1 is 2 minus cosine x all over sine squared x, because that's low squared, all over the square of what's below. And getting closer to being done here with derivatives. 3u squared. So the derivative of 3u squared would be 6u times the derivative of u with respect to x. You could also FOIL this out. But again, if I call the sum 3u squared, bring down the power, it would be 6u du dx. And that'll help us with implicit differentiation soon. All right, so it would be 2 times 3, 6u. Then I take the derivative of this with respect to x, which is a -2, and then that's how it simplifies. 21 and 22 are very similar. Again, derivative of any natural log u would be 1 over u du dx. It's that simple. That's my u. So it's 1 over u. the derivative of this u, which is sine 3x, would be cosine 3x. Then I got to take the derivative of 3x, which is 3. Okay, that's how I can rewrite it. Either of those answers is fine. All right, so 22, you have a natural log u again. So 1 over u, derivative of u, so derivative of cosine would be negative sine of my angle. Then I take the derivative of that angle. Again, I could call this negative 8 tangents, because tangent is sine over cosine, 4x squared. Negative 8x, that is, times tangent 4x squared. But this is also fine. All right, 23, we got the products with a little bit of the chain rule involved, product rule. So I'm going to rewrite, I'm going to make sure I have this rewritten like this, the root part. This is the first, that's the second. Derivative of the first would be 12x squared times the second function plus the first function times derivative of the second. So bring that 1 half u to the 1 power less. Take the derivative of u with respect to x. Just clean it up. So this is just going to be written as root 3x minus 2. 3x minus 2, negative 1/2 power would be 1 over 3x minus 2 in the root. And then this times this, 6x to the third. All right, let's take a look at 24. You got 4 times u to the 1/2. All right, 4 times u to the 1/2 would be 1/2 times 4 would be 2 u to the 1 power less du dx. So 1/2 times, bring out the 4. Okay, bring down the power 1/2 u to the 1 power less. Take the derivative of this, which would be 4x plus 7. And simplified as the following. 4 times 1/2 is 2, so double this. And then this would be down below as a square root. Again, pause this whenever you need to. We are finally finishing up the derivatives. Here's 25. I just rewrote it. Just rewrote that last part, minus 4 over x to the negative second. And then it's just power rule. Bring down the power 1 power less. Bring down the power 1 power less. Bring down, then I made a boo-boo because that should be a plus. Negative 2 times negative 4 is a positive 8. All right, x to the negative third would be over x to the third. And we're rolling. Let's take a look at 26, the last one. Derivative of the first function times the second plus the first function times the derivative of the second. Now, this is not 1, nor is it negative 1. It is just cosine squared x minus sine squared x, which is actually cosine 2x. But if we don't know that, that's okay. So you can either have negative sine squared x plus cosine squared x or cosine squared x minus sine squared x. All right, 27 through 32 say find the equation of the tangent line to the curve at the given point. So you just need to find the slope. What's the derivative here? Derivative, so y prime would be 10x minus 3. That's the general derivative. Then to find the slope of the curve, or slope of the tangent line to that curve at that point, plug 1 in for x. So m is 7, and we're going to use point slope form, which says y minus the y value is equal to the slope times x minus the x value. You know what the y coordinate is, it's 4. You know what the x coordinate is, it's 1, and the slope is 7. Okay, these should be a piece of cake, 27 and 28. All right, so here's my curve. I take the derivative. It's 2 minus 6x. I plug negative 1 in for x, so the slope is 8. Y minus a negative 5 is y plus 5 is equal to 8 times x minus a negative 1 is x plus 1. All right, let's talk about 29. 29, 32, you got some more polynomials. Take the derivative, 6x squared minus 10x plus 7. To find the slope, plug 2 in for x. Slope's 11. Another miss there. All right. Here we're going to use the quotient rule, which says low, d high, derivative of 5x is 5, minus, oh, that's, why I had an issue, minus high, that's clearly 5x. Derivative of low is a negative, should have caught that, is a negative 1. All right, so it's definitely going to change my answer a little bit. 15 minus 5x plus 5x. Get rid of that minus 15. All right, so it's going to be 15 over 3 minus x, all of it squared. That's not the slope, so the slope is 15 over x is a negative 2. So 3 minus a negative 2 would be 5. We're going to square it. 15 over 25 is 3/5. That is the slope. All right, I got the derivative wrong because I just messed up the quotient rule. Minus high and derivative of low is a negative 1. Bad, so it's 3/5 is my slope, not 0. Because I just wrote low d high twice. Obviously, low d high minus the low d high is going to be 0. So that's 3/5 is the slope. So y equals 4 over x at 4, 1. So y is 4 times x to the negative first. Bring down the power, 1 power less, negative 4 over x squared. I'm going to plug 4 in for x. My slope's a negative 1/4. Y minus the y value is equal to the slope times x minus the x value. And 32. Y prime is 3x squared minus 4x. Plug 3 in for x. To find the slope, slope's 15. Y minus the y value is equal to x, to the slope times x minus that x value, that x coordinate. All right, then finally 33 gives you an equation. You throw something in the air with initial velocity of 94, initial height of 24. Wants to know the instantaneous velocity at certain times. First off, the velocity function. Velocity is the derivative of position function. Sometimes you see it with an S. Okay, velocity is that derivative, and then acceleration is the derivative of velocity, the first derivative of velocity or the second derivative of position function. So velocity function, very easy. It's negative 34t plus 94. That is what we use to plug those various numbers for time, those various times. So 1, you plug it in to the velocity function. Plug 1 in here, not here. Negative 32 times 1 plus 92, 62 feet per second. As it goes up to its maximum point, the velocity will be slowing down. And then as it goes down before it hits the ground, it will be speeding up, but have a negative velocity because its distance from the ground is getting smaller. So v of 2, I just plug that into negative 32t plus 94. Then v of 3.5. Then v of 5. All right, and that is it. That is it. Okay, so that is all. Those are all the answers. Watch this a few times for your test review. All right, this is Zach Math Video signing out.